How's it going, ladies and gentlemen? Mr. Johnny here again, looking at 15.6, Le Chatelier's principle. All right, last topic of the chapter. So which of the following equilibrium will shift to the right in response to a decrease in volume? So it may have multiple right answers. If we're decreasing the volume, what we're doing is we're increasing the pressure. All right, and if we have an equilibrium with gases, right? So pressure is only affects gases. So these would all have to be gases. Well, how is pressure going to affect it? The way I think of it is if you got high pressure, you're going to favor the side with less gas. So side with less gas. So if this was my example, x plus y gives me z, and I were to increase the pressure, well, on this side, on the reactant side, there's 2 moles of gas. On the product side, there's only 1 mole of gas. So if I increase the pressure, it would favor making z, which kind of makes sense. If I'm increasing the pressure, I want to favor the side that takes up less space. Less gas takes up less space. So we got to look at these examples and see which ones will shift to the right. So if I'm looking at A, I got 2 gases, 2 moles of gas on the reactant side, and 2 plus 1, I got 3 on the product. So if I were to increase the pressure, it would shift it to the left. So that is not going to be ours. All right, well here, HI got 2 versus 2, right? 2 moles of HI, got 1 H2 and 1 I2, so it's not going to have any effect. It's going to pretty much stay the same. All right, Fe, but that's a solid, so I can ignore that. All right, 3 O2 gas versus 2, that's a solid too, so I got 3 versus 0. Well, if I were to increase the pressure, yeah, that sure would shift it to the right. So C is a good answer. So there may be multiple right answers, so let's keep looking. I got H2 gas, Cl2 gas, so I got 2 moles of gas versus 2 moles of gas. So no effect there. And then I got 1 N2 and 3 H2, so that's a total of 4 gases on the reactants and 2 on the product. So if I were to increase the pressure, it would favor the right side, one with less gas. So yeah, C and D. All right, 31. It says the following reaction is exothermic, but they don't tell you like the specific heat or anything that's being generated. But we do know if it's exothermic that heat's being generated. So heat is a product. So we can put it right there. And it says according to Le Chatelier's Le Chatelier's principle, how could you increase the number of moles of product? So we want to increase the SO3. So we want to shift it to the right. All right, well, there's a bunch of ways to do that. We can increase SO2, because if we add SO2, it'll shift away from the add, right? So if you add stuff, it shifts away. And if you remove stuff, you got to replace it. So that alliteration might help. Add, away, remove, replace. So if I'm adding SO2, I want to shift away, bingo. Same thing for O2. So I can add O2. It would shift away from that. All right. Let's see. We also have heat. Well, heat's a product. So if I want to try and make more product, I got to remove the heat. So cool it down. Remove the heat. You can also, sometimes it's weird with the wording. If we're trying to make more SO3, you could simply remove SO3, because that'll drive the reaction to replace it to make more SO3. So that you could do that. You also, let's take a look at the gases. I have 3 moles of gas on the left side, and I only have 2 moles of gas on the right side. So if I want to favor the side with less gas, well, then I increase the pressure. So I want to increase the pressure. So there's like 5 different ways. 32. What would happen to the following equilibrium if pressure was increased at a constant temperature? All right, so we want to look at just gases. Everything in here is a gas. I got 1 and 1, so I got a total of 2 moles of gas on the left side and 2 moles of gas on the right side. So since they're equal, it would have no effect. Oh. 33. Given the following equilibrium reaction, how could you increase partial pressure of H2? Give at least 2 ways. So we're trying to increase this stuff. So we want to shift everything to the right. So in order to do that, we can remove CO. We can add H2O. We can add carbon. Right? If I add, I shift away from it. If I remove it, I would replace it. For this one, it's asking like, how could you increase the partial pressure? Well, if you removed H2, you wouldn't really increase the partial pressure of it. So if it was asking like, how could you make more H2, then you could say like remove H2. And if we take a look at the gases, I got 1 mole of gas on the left side and 2 on the right. So, all right, how do I get it to favor the side with favor the side with more gases? Well, you want to decrease the pressure. Those are it. And then little 34. What will happen in the amounts of products and each reactant as a result of decreasing the temperature? So again, it tells you it's exothermic. So we know that heat is a product. And if it's saying decreasing the temperature, well, that means we're removing heat. Well, that's going to shift it to the right to replace what's being removed, which means you're going to increase the SO3 and you're going to decrease the O2 and the SO2. So SO2 will go down, O2 will go down, and SO3 will go up. All right, explain the effect of adding a catalyst has on equilibrium. I'm going to give you the long answer. So if we're looking at a potential energy diagram to talk about what does a catalyst do, well, a catalyst lowers that activation energy, which means what for the forward reaction? It's going to speed it up because now it doesn't take as much energy to get it going. But the same is true for the reverse reaction. Now going backwards, it doesn't take as much energy to get it going as well, so it'll also speed up the reverse reaction. So overall, a catalyst has no effect on an equilibrium because it's speeding up both the forward and the reverse reaction. And that's chapter 15, ladies and gentlemen. I hope you enjoyed it as much as I have. Bring questions to class. I'll see you there.